พร้อมไหม Okay. Okay, student. Today we're going to have the laboratory number 2. Is the Poisson ratio of rubber. In this lab, we're going to have the specimen with this black rubber band. We also have the weight here, the ruler, the pen or pencil, the vernier. Okay, the objective of this learning is let you to find the stress strain diagram of the rubber and also to let you determine the Poisson ratio of the rubber band. Okay, to determine the stress, what do we have? We will put the weight into the rubber band, and then if you put, for example, this is going to be 10 and the total of 25 Newton. What happened is the weight gonna produce the stress in the rubber band, and we are going to divide the weight by the area, which is the multiplier of the thickness and the width. You will got the stress. Okay, and before you put the weight, okay, you may measure the original length of the rubber band here, and when you put the weight over here, the rubber band will get some elongation. You divide the elongation with the original length, you get the longitudinal strain. Also, when you pull this one down, not only elongation occur, the contraction of the width also occur. If you measure the width after the weight and then minus with the original width, you got the contraction. And if you divide this contraction by your original width, you get the lateral strain. Okay. By doing that, let us start what we should do. The procedure of this is to measure the dimension of the rubber band. Let's say if we like to have the original length of 120 meter, you select the portion of the rubber band and mark it, okay, on the top and the bottom. And you also supposed to mark at the middle also, and then you should draw the line to make it the reference to our measurement. Okay, and by doing this, you got to determine the area of the rubber band. So what we are going to do is using the vernier. You may measure the thickness one time and then take it back, lick it, and then second time, and then that's loose, and then lick it, and the third time, and take it out. So this is going to be 3 value of the thickness of the rubber band, and then you sum them and divide it by 3. You get the thickness of the rubber band. The area, you got to measure the width of the rubber band also. You take it out and lick it one time, and then the second time take it out and lick it, and then the third time take it out and lick it. So by doing this, you're going to get 3 value of width. You do the average, sum them and divide it by 3. So if you time the average thickness with average width, you're going to get the cross-sectional area of the rubber band. That is going to be the original A. And then since the measure of the ruler may not be that accurate, I encourage you to measure the length, okay, between the top line and the bottom line first time, and also this is the second time, and then you lead to value, and then you're going to get the original length of the rubber band. Okay, and then you got to determine the load that's going to apply to this band. And the first one, I will let the load gonna be 50. Okay, and if you have that, let's put the 50 kilonewton into the rubber band. Okay, you got to put 1, 2, 3, 4, 5 of 10 Newton. And then when you put the weight, you're going to be aware about the position of the weight. Okay, you got to take it into position, and then you will start to measure the length of the specimen again. Okay, this is the length first time, and then second time you read it and you average it. This is going to be the length when the weight is of 50 Newton, and if you minus it by the original length, you will determine the elongation of the rubber band. And then if you divide this elongation by the original length as before, you get the longitudinal step. Okay, and then you do measure again the width one time and lead it. Second time and lead it. And third time and lead it. Okay, by doing this, you do the average for the new width. The number will be less than the previous one, and then you put that number minus to the previous one, you get the contraction of the rubber, and then you divide the contraction by the original width, you get the lateral state. Finally, you can compute the Poisson ratio equal to minus of the lateral strain divided by longitudinal strain. And then the next one, you may increase the weight to the rubber band and do the same step. So you get each of the step, you will get the value of the longitudinal strain, lateral strain, and the Poisson ratio. And also, if you divide the weight by the cross-sectional area, you get the stress. You put the stress into the diagram and the strain into this diagram, you get the stress-strain diagram. And then finally, you can compute the modulus of elasticity of the rubber. So this lab going to be the second lab. Lab number 2, you may read the detail of this lab by the manual. If you need help or need further, if you have further question, just ask me or our TA. They are available for you online or by the email. Okay, thank you everybody. Bye.